Tip number 13. How do you examine the intermediate steps in a pipeline? Use the named steps attribute. Let's take a look at this example. We've got 2 feature columns, 1 target column, and you'll note there's a missing value in the age here. We're creating a pipeline of simple imputer and logistic regression. And then when you fit the pipeline, we're passing it X, which is these 2 features. And it's useful to note that age and p-class are getting passed to the simple imputer. It's imputing any missing values, and that transformed version of X gets passed to the logistic regression model for fitting. Okay, so that's what happens when you do pipe.fit. It actually has quite a long output, so to save on screen space, I just used a semicolon at the end. That's a little IPython trick for suppressing output. And IPython is the kernel used by the Jupyter Notebook. Okay, so let's get to the meat of this, which is name.steps. So I've done the fitting, and I want to inspect the imputer that was in the pipeline and the logistic regression model that's in the pipeline. I access it by named steps. So I do pipe.nameSteps, and then I select the simple imputer step, and then I can access its statistics attribute. And what is that? This is actually the mean of each of these 2 columns. The mean by default is used for imputation by simple imputer. And even though there's no missing values in p-class, it collects the mean of p-class in case you have any missing values to impute in the new data, even though there weren't missing values in the training data. Now, how did we know the name simple imputer? Well, the first way, you could just type pipe.nameSteps and it'll show you the named steps. But we know it's called simple imputer because when you use the make function, it by default just uses the lowercase version of the class. So instead of simple imputer with capitals, it's just simple imputer all lowercase. If I was using pipeline instead of make pipeline, I could define this name myself. Now, we can also access the logistic regression object and its coef attribute. So these are the model coefficients, and for what it's worth, what we're seeing is that an increase in age slightly increases the likelihood of survival. An increase in p-class decreases the likelihood of survival. You'll understand that if you're familiar with logistic regression and how that works.